So let's get started with Matplotlib. We're going to start on the desktop and do what we always do and hit the terminal. Beautiful. I'll zoom in a little bit on here. Excellent. Now we're going to go through our little workflow like we always do. So we're going to CD, for me, I'm going to get into the sample project folder, which contains our environment. Remember, we can always see our environment by using conda end list. So this will show me my environments. This is the one I'm after here, sample project, the folder we've been working through before. So I'm going to CD, I'm on the desktop right now. We can see that there. So I'll go into ML course. We can see that little folder up here, but we're going to use the command line. And then CD again into sample project. Beautiful. And then we can run conda activate. Now you could just copy and paste this and do that there. But remember, we're in the habit of typing out code. That's the best habit you can develop. That way you get used to writing things out for yourself and practicing, seeing what it feels like on your fingers to write code. So if we go conda activate, that should be all correct. Wonderful. And so we've had base change from this to this. We've seen all this before. I'm going to load up a Jupyter notebook, our favorite workspace. We've got introduction to NumPy and pandas. We've been through those. We're going to start a new one. So now we're going to retitle this one to be Introduction to Matplotlib. Beautiful. We'll have a title, Introduction to Matplotlib, just so we know what's going on. We're in the habit of communicating what we're doing. There we go. Beautiful. And so now we're in a Jupyter notebook. The first step for always using Matplotlib is we might import NumPy and pandas as well. So we'll import all the tools we need right at the top of the notebook. This is kind of a regular workflow. So the first one we'll do is matplotlib inline. Now, if you've never seen this before, this little percentage sign, you might have in a previous video, but this is a magic command. So this percentage sign is telling Jupyter, hey, we want all of our Matplotlib plots, our graphs and visualizations to appear within the notebook. So that'll make more sense once we run it. So let's import matplotlib.pyplot. Now, pyplot is a Python plotting module of Matplotlib, and the convenient name is as PLT. We'll also get pandas as PD and import NumPy as NP. Then we'll hit Shift Enter. This might take a little while depending on what's going on. Beautiful. So now we should have all these tools accessible. Now, simplest way to create a plot in Matplotlib is with plt.plot. So if we go Shift Tab, have a look at what this says. Plot X versus Y as lines and or markers. What happens if we just run this? Okay. We get kind of that empty box that we saw before. That was in the Matplotlib workflow. So this is our create a plot. This is our figure that we've just created. So we'll go back to our Jupyter notebook. This is our figure that we've just created. But for some reason, the output, it's giving us these empty brackets. So to get rid of those, you can put a semicolon at the end of your plot call. So let's do that. Same thing, we just don't have that nasty little output there. This is what Matplotlib inline means, is that this plot is in the notebook. So we can see it visually right here. That's all Matplotlib inline means. If we didn't call this, it would just output something like this with no plot. So that's what this line of code is doing. So it's an ideal scenario to always run that when you want to run Matplotlib plots. And now, if we didn't want to use the semicolon, if we wanted to be a bit more communicative, we could go plot and then plt.show. That's going to do the exact same thing. We've got a nice and blank plot here. Now, how about we add some data? So we go plt.plot and then hit Shift Tab. Plot X versus Y as lines and or markers. And if we click the plus sign, it gives us a little example here of plot X, Y. So how about we pass it X as a list of some sort. So maybe we'll just keep it nice and simple. 1, 2, 3, 4. And we'll put the semicolon at the end and see what happens. There we go. We've got a line. And so this is on the X-axis. We should have 1, 2, 3, 4. Okay, beautiful. So what can we try next? Well, let's create some X and Y data. X, 1, 2, 3, 4. Wonderful. Y equals Let's mix it up a little bit. 11, 22, 33, 44. Wonderful. Now let's see what these look like. Plot.plot x, y. And we'll put a semicolon at the end. There we go. We notice that our axes have changed. So now we've got from 1 to 4 on the x and from 11 to 44 on the y. Okay, that's starting to make a bit more sense. This is looking good. Now, this way of plotting in Matplotlib is referred to as the stateless way of plotting. And if you've ever used MATLAB, it works like that. But if you haven't used MATLAB before, not to worry. Let's have a quick look at Matplotlib documentation. Because in there, it tells us a little bit about different types of plotting in Matplotlib. What do we want? Documentation, tutorials, PyPlot tutorial. So this is the type of plotting that we're using at the moment. We've got Matplotlib. PyPlot is a collection of command-style functions that make Matplotlib work like MATLAB. Yep, that's what we just went through. Each PyPlot function makes some change to a figure, creates a figure. So I've been calling these plots. They're also referred to as figures. Creates a plotting area in the figure, plots some lines in a plotting area, decorates the plot with labels, etc. In matplotlib.pyplot, various states are preserved across function calls. Okay, we're just reading the documentation here. So this is the one we're paying attention to. Note, the PyPlot API is generally less flexible than the object-oriented API. So remember how I said there's two ways of plotting in Matplotlib? Well, we've just looked at the PyPlot API, and we're going to look at the object-oriented API in a second, but this is the one we're going to be focused on most, the object-oriented API, because we want as much flexibility as we can get, right? There's one more thing I want to show you. So if we go Matplotlib lifecycle plot, the life cycle of a plot, there we go. And you can get to this in the documentation as well. So this is just matplotlib.org, tutorials, life cycle of a plot. There we go. This says the same thing. In general, try to use the object-oriented interface over the PyPlot interface. Okay, so if the documentation is saying these two things in bold notes, we might listen to it, all right? Because the people who write these documentation, they really know what they're doing. So let's see. This is the first method. We'll go fig equals, now fig is short for figure, plt.figure. This creates a figure. Ax is short for axes. So remember, this whole thing is a figure, but these two lines here are axes. So ax equals fig.add subplot. This adds some axes. Plot.show. There we go. So this has just replicated exactly what we did. We did like a kind of a long version of going plt.plot. Same sort of thing here, right? So this is the first method. And then we've got the second method. So we want fig equals plot plt. And when I say plot, I'm referring to plt, but because there's no O, it's just easier for me to say plot. So creates a figure. We're being communicative here. You don't need these comments. Ax equals fig.add axes. And then within here, we're going to add some sample data, 1111. Oh, sorry, these are going to add axes. So these add axes to the figure. So there we go. We've got another figure. If we want ax.plot, let's get our x and y on there. And then plt.show. Add some data. There we go. We're just creating the same plot. And now finally, we're going to go with the third method, and this is the one that we're going to be using. So we'll put in here recommended. The reason why I'm showing you all these is because if you look up Matplotlib online and you find some documentation or some Stack Overflow answers, you might come across these styles of plotting. So we're going to use a third method. Now this is recommended. Of course, you can choose your own, but this is what we're going to be going through throughout the rest of the Matplotlib section. So this is fig, comma, ax this time. So we've saved a line of code equals plt.subplots. Now let's see what this says. Subplots. Create a figure and a set of subplots. This utility wrapper makes it convenient to create common layouts of subplots, including the enclosing figure object in a single call. Now, what is a subplot? You can think of a subplot as having more than one plot come out at the same time. That's all it really is. And then we're going to go ax.plot x, y. Add some data. And we'll put a little semicolon at the end instead of calling plot.show this time. There we go. We've just recreated the same graph 3 times with 3 different methods. But we're going to be focused on the third method. And you might notice that every time I call something like fig equals or ax equals or fig comma ax equals, it resets the figure. Even though we're plotting the same data, maybe if we went here and we go 50, 100, 200, 250, it's going to change it up. So every time we call something like this, it's going to reset the figure and plot a new set of data. So let's wrap it up there. But in short, the main takeaway from this lecture is that we're going to be focused on this method. There's 2 different types of methods, plotting in Matplotlib, the PyPlot API, but that's generally less flexible. It is quicker to get plots up and running sometimes, but the object-oriented API is going to allow us to do a bit more fancy stuff in the future, so that's what we'll focus on. I'll see you in the next video.